Howdy, this video will cover solving system of equations by substitution. Okay, next. What is substitution? Don't freak out about all this writing, because all I want you to write is solving by substitution is a method of solving a system of equations. Yeah, that's it. So a method of solving a system of equations. Rest of this is just the steps, and that's going to be the next slide. Okay, pause it if you still need to write more. Steps for substitution. Step 1, Step 2, Step 3, Step 4, Step 5, and then you get solution acquired. I just have this just for visual to show you the process that we take, but it's a whole lot more simple than what this looks like. Pause if you need to write more. Good question. We cannot, why can we not, wait. Oh, I wrote this wrong. Why can't we solve for a variable, then plug that variable back into the original equation? Well, we can't do that because when we use substitution, we have two equations. We're solving for two equations. But whenever you plug the solved variable back into the original equation, it's like solving for the same equation, which means we have two of the same equation, which means that we have one line, therefore there's really no real solution. So let me show you an example. Let's say we have x minus y equals 1, and I want you to solve for x. So in order to do that, we need to add y to both sides in order to get rid of y. And we'll be left with x equals 1 plus y. Now, go ahead and use substitution and plug that back into your original equation. So since x equals 1 plus y, replace that x with 1 plus y. So by doing that, we have 1 plus y for x, and then minus y equals 1. Now we're going to combine like terms, which is y and y. So y minus y cancels. So we're left with 1 equals 1. We don't have a variable equaling a number. We have a number equaling a number. But is this a true statement? Does 1 equal 1? It does. So, therefore, if we have a true statement, so true statement, then this system is called dependent, meaning there are infinite solutions. Now, what if we have an untrue statement? What if we have 1 equals 0? Okay, so that's going to be untrue. And whenever you have an untrue statement, so 5 equals 0, 6 equals 4, those are untrue, those don't equal each other, then that means we have an inconsistent system, and there is no solution. Okay, moving on. Pause if you need to keep on writing. Okay, first example. Given 2x minus 3y equals negative 2 and 4x plus y equals 24, solve the system of linear equations by substitution. Now, whenever we solve by substitution, the first step is to solve for a variable, just one single variable. Now, we have 4 of those. We have an x, we have a y. We have an x, we have a y. Which one of those 4 is easiest to solve for? Ask yourself that. Which one is easiest to solve for? And that would be this y, because all I have to do is bring that 4x over in order to get y by itself. So let's go ahead and do that. We have 4x plus y equals 24, and we want to get y by itself. So let's go ahead and subtract 4x from both sides. And we'll be left with y equals 24 minus 4x. Now, using substitution, plug our variable back into our first equation. So using a visual, plug that in for this y, because y equals 24 minus 4x. So let's go ahead and do that. We have 2x minus 3, and then since y equals 24 minus 4x, inside your parentheses put 24 minus 4x. And that's going to equal negative 2. Now, the distribution property. We're going to take this 3 and distribute it inside our parentheses. So now we have 2x minus 3 times 24 is 72. And then negative 3 times negative 4 is positive 12. So we'll have 12x equals negative 2. Next, we need to combine our like terms, which is 2x and positive 12x. 2 plus 12 is 14. So we'll have 14x minus 72 equals negative 2. Now, we're still solving for x. So that means we need to get x by itself, meaning this 72 needs to go away. So in order to do that, we need to add 72 to both sides because it is negative. So that'll cancel. And we're left with 14x equals negative 2 plus 72 is going to be 70. Last step to solve for x. We have 14 times x. Opposite of multiplication is division, so we're going to divide everything by 14. And x will equal 70 divided by 14 is 5. Now, that's half our solution. We now need to find y. So we're going to plug this x into either equation. Let's go ahead and use this one here. So instead of using our x, we're going to use 5. We're substituting 5 in for x. So, doing that, we have 4 times 5 plus y equals 24. And 4 times 5 is 20. 20 plus y equals 24. And then last step, we need to get y by itself, so subtract 20 from both sides. And we'll get y equals 4. Because 24 minus 20 is 4. And that's our solution. We have an x, we have a y. Boom. Whenever we have an x and a y, it's going to be independent. Alright? Next. Alright. Given y equals 36 minus 9x and 3x plus y over 3 equals 12, solve the system of linear equations by substitution. Now, first step is to solve for a variable. But look at here. We already have one solved for. So what we're going to do, we're going to take what y equals, 36 minus 9x, and replace this y with that. So let's write it out. 3x plus 36 minus 9x divided by 3 equals 12. Now let's go ahead and simplify. So let's divide by 3. So if we have 3x plus, what is 36 divided by 3? 12. And then what is negative 9 divided by 3? Negative 3x. And then equals 12. Now combine our like terms, which is 3x and negative 3x. 3x minus 3x cancel each other out. So we're left with 12 equals 12. And look at there. We have a true statement. This is true. So if we have a true statement, what kind of system do we have? Dependent. And we have infinite solutions. Okay, now, last example, our third example, given 7x plus 2y equals 16 and negative 21x minus 6y equals 24, solve the system of linear equations by substitution. Now, this is a higher level question. No matter which variable we solve for first, we're always going to get a fraction. And we don't want fractions. Fractions make it complicated. Well, make it more complicated than it should be. Now, one thing we should think of reducing. We should simplify. Do either of these equations simplify? And yes, they do. This one right here, a negative 21x minus 6y equals 24, reduces. What number goes into all three of these? 3 goes into all three of these. Now, if we look at this, 21 divided by 3 is 7. And we have a 7 here. So, what number do we divide negative 21 by to get positive 7? And that would be negative 3. So, just to make it simple, easier on us so we can think about solving for x and y, let's go ahead and divide this entire equation by negative 3. So, if we have negative 21x minus 6y equals 24, let's divide every single one of these by negative 3. We're just reducing it. So negative 21 divided by negative 3 is positive 7x. Negative 6 divided by negative 3 is positive 2y. And then 24 divided by negative 3 is negative 8. Now, look at this. We have a 7x. We have a 7x. That's good. Now we can simplify without getting fractions. We can substitute without getting fractions. So if we solve for this 7x, 7x will equal something. And then we can replace this 7x with what 7x equals, and then solve for y. So let's go ahead and do that. Let's solve for this 7x. And in order to do that, we need to subtract 2y from both sides. And we'll get 7x equals negative 8 minus 2y. Now we can take this negative 8 minus 2y and replace this 7x with that, because 7x equals negative 8 minus 2y. So let's go ahead and do that. Let's write it out. We'll have negative 8 minus 2y for 7x, and then plus 2y equals 16. Now combine your like terms. Negative 2y plus 2y, that cancels. And we're left with negative 8 equals 16. And look at that. That is not a true statement. Negative 8 does not equal 16. Therefore, we have what kind of system? Inconsistent. And we have no solution. Okay, and that's the video for us. Everybody, thanks for watching. Don't forget to pause and rewind if you need to catch up on something. Don't forget to take your notes. Don't forget to print out your worksheets. Do your work. Please turn it in. All right. Thanks for watching. Bye.